Hello, welcome back. We're going to continue our discussion on solving differential equations by separation of variables. So if you would like, go ahead and pause the video and you can try number 4 here on your own. I'm going to work it. We are going to, of course, multiply both sides by the y and the dx. We're just going to cross multiply here. So remember, we're going to get y dy equals x minus 3 dx. Remember, you want x's to one side, y's to the other. You don't want them on the same side. And the AP is going to reward you just for a point for that. And now we get to integrate. That's going to give us y squared over 2 equals, over here, x squared over 2 minus 3x. Don't forget the plus c. Remember, we don't need to put a plus c here. We only need to put it over here. And of course, our next step is to find c1, given the initial condition to -5. Remember, be careful of the signs here. We're saying y is going to be negative in this case. So when we plug in our values, we have a y, we have our x, and we're going to plug it into our function. There's y and there's x. Plugging in, we get -5 squared, which is 25 over 2, equals, plug in here, we get 4 over 2 minus 6 plus c1. I'm going to simplify here. This is just going to be, what's that? 21 over 2 equals -12 over 2 plus c1. So c1, if I multiply out, gives me 33 over 2. I'm not worried about making it nice. Just want to get an answer. So I'm going to plug that into my equations. We would get y squared over 2 equals x squared over 2 minus 3x plus 33 over 2. Solving for y, let's do it in one step here. I am going to multiply by 2 and then take the square root all at the same time. But remember, I get two answers, plus or minus, and that's going to give me x squared minus 6x plus 33. Now, even though we're only going to pick one of these, you still need to put both. The AP needs to know that you know the algebra here. We only want the negative one. That's what my rule says here. So we pick the negative, and therefore we would get y equals negative square root x squared minus 6x plus 3. And there's our answer. All right, let's take a look at one that's not going to give us a square root, because these are getting honestly kind of boring. So let's take a look at number 5 right here. For number 5, we're going to separate out again. And this is going to give us 4y squared dy equals x squared minus 8 dx. When we solve it, when we integrate, this is going to give me 4/3. Whoops, that's a weird looking third. Don't tell anybody I did that. There we go. We get 4/3 y cubed equal to x cubed over 3 minus 8x plus c1. Make sure you don't forget this plus c1. Now using the initial condition, find c1. My initial condition, 0, -2. So when we solve it, plugging in this is my x, there's my y, I'm going to get 4/3, whoops, a negative cubed, 2 cubed is -8, equals, plugging in 0, we get 0 cubed minus 0 plus c1. So we get 0 minus 0 plus c1. So c1 is just going to be negative 32 over 3. Plugging in, we get 4/3 y cubed equals 2, x cubed over 3 minus 8x minus 32 over 3, and solve for y. I am going to invert to multiply everything by 3, and that's going to give me x cubed minus 24x minus 32, but then I'm going to divide everything by 4. That becomes over 4, over 4, over 4, and now I'm going to take the cube root. Now when you take a cube root though, we don't have to worry about the signs on the cube root because it's always positive or negative, it's just going to be the same. So we're going to get the cube root of x cubed over 4 minus 8x, whoop, that should be a 6x. This is why I never simplify. 6x minus 8. And there's a function. There is no plus or minus on here because a cube is always positive or always negative. It doesn't really matter. That's an odd function there. All right, a little bit different problem here. This one shows up on the AP every once in a while. It says, find the value of b for which y equals 2x plus b is a solution to this differential. So notice we want to make sure that the derivatives are equal to each other. So if I take the derivative, if y equals 2x plus b, I know that the derivative dy dx has to equal 2. So I can say that 2 equals this 2y minus 4x, like so. Now the next question says solve for b, right? I want to solve for b. Well, what is y equal to? I can just substitute that in. I know what y is equal to, so I would get 2 equals 2 times 2x plus b minus 4x, distributing a little bit of algebra. Whoop, that's a terrible distribution. 4x plus 2b minus 4x. X's cancel, solve it, b is just 1. Cool little algebra problem right there. And for number 9 here, this is actually on your homework, so I'm not going to do the whole thing. You want to do a slope field, we'll do that in a little bit. But what I want to do is I want to take a look at part C here. This says find the particular solution. Now, in my first video in this day, we talked about a particular solution is just basically saying solve the differential. And that's what we're going to do. We have our differential up here. dy dx is y minus 1 squared cosine of pi x. And I want to solve that, given the initial condition f of 0 is 1. F of 1 is 0. Sorry, that's terrible. So we're going to say dy dx is y minus 1 squared cosine pi x. So when I solve it, I am going to separate out by bringing my y's to one side. And that's going to give me 1 over y minus 1 squared dy equals cosine pi x dx. When we integrate, we're going to use u substitution. So I'll do u substitution over here. We will get u is y minus 1, du is just dy. And that's just going to give me, if we were to rewrite this, there we go. If we were to rewrite this, we would get u to the negative 2 du, which is negative 1 over u. And we can simplify, and that's just going to become negative 1 over y minus 1 equals, I ran out of room there, so if I replace my u. Over here, we're going to let u equal pi x. Our du is pi dx, so dx is du over pi. So when we rewrite our integral, we will get 1 over pi cosine u du. Now, I know this one. This is just 1 over pi sine u plus c1. The antiderivative cosine is sine. Remember, you want to have this. This right here will be worth like 3 points on the AP alone. That's worth a lot of points right there. I'm going to replace my u. We will get 1 over pi sine of pi x plus c1. And now we are going to find c1 by using the initial condition 1, 0. There's x and there's y. Just plug in. If we were to plug in, we would get negative 1 over, plug in 0, negative 1 equals 1 over pi sine of 1 pi plus c1. Oh, look how nice this is. This turns out brilliant. Look at this. This becomes 1 equals sine of pi is just 0 equals to c1. So c1 is just 1. Oh, how lovely is that? So what we're going to wind up with is negative 1 over y minus 1 equal to, and I'm going to write this as sine of pi x plus 1. Whoop, sorry, that's over pi right there. Now, there is kind of a trick to this one. We can't solve for y directly. So the first thing I'm going to do, now we're like 99% there. So the first thing we're going to do is I'm going to divide everything by negative 1. 1 over y minus 1 equals negative sine pi x over pi minus 1. Next, I have to get a common denominator. So I'm going to get 1 over y minus 1 equals my common denominator on the left. On the right side is just pi. That's going to give me negative sine pi x minus 1. And now I can flip them. And that's going to give me y minus 1 equals pi over negative sine pi x minus 1. And then I add 1. Whoops. Can't add 1 right. There we go. We would get y equals pi over negative sine pi x minus 1 plus 1. And there we have it. All that for 1 point. All right. Hope you guys enjoyed this video.